And the more interesting bit about whole numbers is that whole is not the issue. It is the number. Number the idea of number makes it complex. Okay, whole number is actually because the counting numbers are like the natural numbers. Okay, yeah, we'll come to that. But the complexity arises because we don't understand the whole idea of numbers. Okay, uh, and it's not true for whole numbers. It's true for all. Even fractions are like that. Rational numbers are that. Integers are like that. Negative numbers like that. Okay, it is the number part which makes it more complex. Okay, uh, and that complexity arises because numbers are codes. Okay, numbers are coded digits. They follow a particular pattern uh, uh, in reading it. So when you read a number, when you read, say, for example, 67, it is not 6 and 7. There's a code to it. And that is not well elaborated. There's a huge hole there, actually. Even fraction 3 by 4, okay, 3 by 4 is a code. Okay, even integer minus 1000 would be loss if 1000 is profit. It's a code. To know what is minus 1000, I need to know what the positive side is. What would be positive 1000? Okay. Okay. I mean, if the positive 1000 is actually profit, then the negative 1000 can only be loss of that amount. So it's just link. All the numbers are actually codes, and unless you understand, you know how to read that code. The simplest of numbers, like the whole numbers, will be complex enough. That's the first idea. We'll start with the idea of numbers as codes. We will take us through the codes that we use in our daily life. We use significant amount of codes in our daily life. In fact, time is a code. When you say 11 hours, 11:55, 20, it's a code. 11 hours, 55 minutes, and 20 seconds. Pin code or the zip code is a code. Okay. Well, in the case of the wired telephone numbers, it was a code. So the code took you to a state, the country, and the state, and then the district, and then your home. The number took you to a particular phone number. So to understand numbers as code, we have to go back to see how do we make codes actually. Okay, what are the features or the characteristics of the common code that we use? And the interesting bit is the same kind of code we use for numbers as well. So there's a lot to be learned from how the zip codes are made or how the time code is made to actually then learn to read numbers, decode the numbers. So that was that's the plan that we will follow. And once we have understood numbers, and in numbers itself, we will in understanding numbers as code itself, we will discover the face value and the place value. The face value of the digits in the number, the coded digits, the values of the places in the code, and the place of value. All the three will be sharply obvious and clear. I also don't understand why there's so much hue and cry around place value and face value. Is so simple, stupidly simple in the idea of a code. If the zip code, so America has 5-digit zip code, isn't it? Okay? It has just 4 parts, 4 distinct parts, and 5-digit code it is. Okay, and so if a particular zip code is 2, then the 2 is the face value, and it might represent, say the central Midwestern, America. So all the states in that region will have, the digit 2. The face value of the digit will be 2 in that region, and the meaning will be, the place value will be those states. So and the same holds for their numbers. Okay, where are the numbers? The we do mention, when we teach numbers to children, that these are called positional number system. But unless you teach them code, how do you explain what are the positions? What are the places? So when we start our first lesson, we'll start with numbers as codes. We'll learn to decipher codes, and then we'll apply the same things to numbers as codes, and then figure out for ourselves how 4, the number 4 only is same as 04, but it's not same as 40. Because the position of 4 would have shifted. The position of 4 would have shifted. In 04, 4 is still the first digit. But in 40, okay, 4 and 0, 4 is the second digit. Shifted position. And 203 and 20003 are different numbers, because 2 and 3's positions have shifted. Or 3 has remained, 3 has remained, but the 2's position has shifted. So it's just, the idea of numbers as codes quite holds the key to understanding number behavior, what they are, how numbers are created, and then whether they are whole numbers or they are integers. In fact, in most textbook and syllabus and curriculum, whole numbers are actually misunderstood as whole meaning integer whole sense. To me, that is integer. Whole number only meant that they made the category of quantification whole. Okay, the addition of 0 to the natural numbers made numbers pretty much whole or full for most situations in our daily life. Yes, integers or the idea of negative numbers is a purely human creation. Okay, thus the natural number plus 0 is good enough to actually explain most of the things in our lives. And that is also the idea of understanding 0. What is 0? There's again a significant confusion around what is 0. What is 0 and what is nothing? For example, to a question as to how many moons are there on Earth, the answer is not 0. They're not supposed to be moons on Earth. So it's not 0. So to understand where we use the 0 to explain something not being there is again very significant, because that understanding of 0 is carried on to 0 as placeholders. Unless you understand that 0 means this, a particular definite meaning of 0, you cannot understand 0 as placeholders in the decimal system. So we will go through this, understand numbers first, and then the idea of whole numbers, and then the idea of integers, then the idea of fractions. Okay, so I thought that's where we could start whole numbers, which is the first chapter for grade 6. Yes, and at one level, teaching whole numbers in grade 6 is ironical, because it's the simplest set of numbers that we have created. Why do we teach them in grade 6? Okay, but 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 because we don't do a good job of actually bringing the idea of number itself. And another thing, actually, to me, there's this confusion or lack of proper understanding of whole numbers, also because we only teach decimal numbers, and I call it decimal decadence. Only learning the decimal system as the only default number reduces our ability to appreciate numbers. It is actually decadence. So rather than growing, we are actually depreciating. You cannot really appreciate decimal number unless you appreciate at least one more number like binary or octal or ternary, whatever. You need to understand one more number system. Yeah. For example, I mean, how do how do we tell children or anyone for that matter that 0 to 9 does not, the use of only the digit 0 to 9 does not make it a number, decimal number for sure. Because hexadecimal also will have 0 to 9 and more, but of course, 999 could be decimal or hexadecimal or anything else which is bigger than base 10. But the whole system says 0 to 9 means decimal number. Only because we don't introduce the idea of another number system. It is patently wrong. It is absolutely wrong to say that if a number has between 0 to 9, it is a decimal number. No. You can't say that for sure. It could be a decimal number, but that's not a test of a number being a decimal number. So there are although some of the gaps around the idea of numbers, positional numbers, which makes this understanding poor.
Yeah. Wow. So I think that in the first few weeks, go ahead, sir.
No, please go ahead.
So I think that on Saturday, we'll have more time to talk, but I think that parents, who will be watching this need to know that we are going on a journey from the fundamentals, the very beginning, and we need to get rid of some of the ideas we've learned before, and we need to take on a new way of thinking of certain things. We need to be open to the fact that the way mathematics might have been introduced to us is one of the reasons we are not doing as well in it. And so I look forward to starting from helping people understand the nature of the basics. I love that you talked about zip codes. I love that you gave those examples. I think that when we realize how math is embedded into everything everywhere, we begin to realize that you shouldn't hate mathematics. If your child hates mathematics, they are learning it wrong. It's not something they should be hating. It's beautiful. There's no reason they should hate it. How we teach it is the problem. How we teach mathematics is the problem.
Yes, correct.
And every teacher...
actually, maths is the easiest domain of knowledge.
It's the easiest. Yeah, I was going to say that.
Yeah. I mean, you cannot imagine.
Go ahead. You said you can't imagine?
No. Yes. No. So I mean, I cannot imagine a more easier domain of knowledge. For example, English has 26 alphabets.
Yes.
Math, 10 alphabets. Decimal system.
Yes.
English grammar could run into a few hundred pages.
Yes.
Math grammar runs into 4 pages. four A4 pages.
Wow.
English language has, I don't know, so many conventions. Math has about 10, 12, 13, 15 conventions, which are also logical. Okay, we write numbers from right to left. Okay, I mean, but in terms of unit and tens and all that, we could have as well written from left to right.
Yeah,
we just agreed. Coordinate we make at 90 degree. It doesn't have to be 90 degree. Okay, it just makes more sense. So math has so little. Secondly, math has school mathematics, I'm saying K-12 mathematics. Okay, whenever I say math, I mean K-12 mathematics. That boundary is there. Okay, so K-12 mathematics has about 10 different strands, 12 different strands. It only runs deep. It is the smallest domain of knowledge.
Wow.
Mathematics, K-12 mathematics is the smallest domain of knowledge in K-12.
Wow. Wow.
It's just not taught mathematically. That is, we don't teach the mind, we teach the methods. That is the problem.
Wow.
Once you start addressing mathematics to the brain, okay, there's nothing more easier actually. And it is, to me, Facebook had banned my ad because I had used the word God in it. I say it is ungodly for a human child to be struggling in mathematics.
Wow.
It's just not possible. A human child cannot struggle in mathematics.
Wow.
It's just not possible. It's not possible. So it's a very so we learn mathematics much less for mathematics. It is to mathematize the mind.
Wow.
To put mind on a thinking path, which is creative. For example, okay, I mean how creative mathematics is. One of my favorite example is, imagine 8 apples, okay, with 1 apple bitten, 1 bite taken off. How many apples are there? So if my unit of counting is 8 apples, then there are 0 apples. If my unit of counting is 4 apples, okay, then there are only 4 apples, because other 4 do not match with my unit of counting 4 apples. If I have 7 apples, if my unit of counting is 1 apple, then I have 7 apples. If my unit of counting is a pair of apples, then I have 3 pairs of apples. It's just amazingly creative.
Yeah.
The same 8 apples, 1 bitten, 1 bite taken off it in one of them, totally changes the quantity. It's just amazing. It's just amazing.
Wow. I think that one of the things that occurred to me recently is that when I think about AI and what it has done to us in society, what AI has done is that it has almost leveled the playing field in terms of having to relearn everything again. So if we're going to relearn, then let's relearn it properly. And so what I mean by that is that it's such a new technology that, AI has made everybody illiterate. It has made everybody illiterate in a sense. It has made everybody start from scratch. And so instead of us building back, using the same old methods, we need new methods. We need a new way to do it. And that's what we're trying to do. We're inviting parents into a new world. We're not doing it the old way. This is the new way. And the new way is we are, as you call it, mathematizing the mind. We're helping people to understand the nature of mathematics, the nature of numbers, the nature of there's just so much to learn. And there's so many children right now that think they understand mathematics. And they say they don't like it because they think that's what they were learning. They were not learning mathematics. A lot of them were not learning mathematics. But here's the problem. If you don't know mathematics...
Mathematics is not. K-12 mathematics is not mathematics.
Correct. That's what I mean. K-12 mathematics is not mathematics. Correct. And that was when you and I met. When you and I met, that was when I knew that we had a project to work on. The moment you said the same thing I was saying for all these years, I knew, okay, we have to get to work. We have 1 billion students to reach in the world. They need to learn what we're saying. Because the thing about mathematics, it's very important and all of that. But here's the thing, though. If you don't know mathematics, I'm talking of mathematics now itself, the real mathematics. If you don't know the real mathematics, you are actually going to be stuck in terms of career preparation, if that's your concern, because you're not going to have the skills to do most of the careers that might even be out there. Definitely not to do with AI. You can't become an AI engineer if you don't know mathematics. You can't become a data scientist if you don't know mathematics. But that's not the only reason we should learn mathematics. I believe we should learn it because it's beautiful.
Yes.
Period. It's beautiful. And then if you want to go become an engineer, that's fine. But math is beautiful.
So, and I would want to add two more things actually. It is impossible not to learn mathematics. You are born with it. Actually, to be honest, I quote in one of my books that is all of us means every one of us who has ever born on earth, okay, has born with all the mathematics that will ever happen.
Wow.
We are all born with the mathematics that will ever happen. Because it's the only domain of knowledge which you can sit in a room all your life with pen and paper and produce 30 PhDs.
Wow.
You don't have to step out. It's just here. It's just here. It's just here. I mean, in a domain of knowledge like physics, which is very, very practical. Physics is the most practical knowledge that we know of. Okay, the most earthy, the most physical knowledge. In physics, there are more theoretical physicists or mathematical physicists than experimental physicists. Can you imagine?
Wow.
Yes. Something which is so real, so physical, so true, has more mathematical and all. Einstein, Newton, Feynman, they're all armchair physicists. They didn't do any experiment ever in life.
Wow.
They logicalized reality using the language called mathematics.
Wow.
Then they saw it here. Actually, the word thought experiment was given by Feynman in 1932.
Feynman. Wow, Richard Feynman.
So somebody insisted. Correct. Somebody asked him, insisted, how do you do physics actually? He said thought experiments.
Wow.
Here, I see them here. So that is mathematics. So you cannot. I said that magic not you cannot not know mathematics. You have it already. What you have been told or taught or seen is actually unmathematical. First. Second, I say that I write history today. I write political science today because I think mathematically. It's a different mode of thinking. It's a very refined way of thinking. In fact, I don't know if you know this fact. There has been no polymath almost, okay, no polymath who was not a mathematician. Even women polymaths have been mathematician. You cannot be a polymath without being a mathematician or no math good in math. Period.
Mm-hmm.
That was mathematics does to you. Mathematics is the most polymathic ability, seed. So math is easy first. Okay, you have it. We will. I mean, when you work with us, we say that it is impossible for you not to excel in mathematics. Period. Yep. Okay. Second, mathematics is the foundation for polymathic abilities.
Yep.
If you want to be good in music and art, you have to be mathematical.
Yeah. Wow.
Yeah.
I'm excited, and I think that we're going to take 8 weeks and let's finish primary 6 maths, 6th grade in 8 weeks. We're going to finish those key topics, whole numbers, integers, fractions, everything. And so parents can join, students can join, and we have work to do. And I'm very excited. Yes. Where are you calling us? Where are you based again in India?
Delhi.
Oh, Delhi. Okay.
I'm traveling till tomorrow, but Delhi.
You're in Delhi. So I'm based in Austin. So I just want us to let you know, we'll let the parents know that it's from Austin to Delhi. We're changing the world. From Austin to Delhi, and both of us. Both of us are also involved with the children in Nigeria. So it's US, India, Nigeria, working with students all across the world. But those are the 3 places that our students are coming out of. I look forward to, putting some of these recordings online and then inviting people to start, registering to join the webinars. We're going to start live streaming the next time. We'll actually live stream. So live stream, of course, means that they will see it pop up and they can watch.
Absolutely. So, correct.
Yeah.
We should just do one full edition, just live, let people come and go and see. That then creates a base for us, and then people join later on. Absolutely.
Yep. Yeah. So that sounds good. The world should get ready. Something has come, something new. And we want to see students who will change the world. So no, thank you so much for all of that. I will I'll have the Zoom link ready, and then we'll connect again on Saturday. So yeah. Yes. Well, thank you. Yes. Perfect. Take care.
Okay. Good day to you. Good day. Thanks.
Yes.
Yeah.
Thank you so much.